everyone, Ali here. Today's problem is called Subarray Sum Equals K, and it's been asked by these companies. Now, let's solve it together.
The question says, given an array of integers, which is called nums, and an integer called k, return the total number of continuous subarrays. So this is important that we are looking for continuous subarrays whose sum equals to k. Okay, for example, if nums array is 1, 1, 1 and k is 2, how many continuous subarrays we can find? So we should search for the subarrays that their sum are equal to 2. So for example, the first subarray would be this one, and the second one is this. So the output is 2, which means we have 2 subarrays that their sum are equal to 2. Or when nums array is 1, 2, 3 and k is 3, what do we have? We have this subarray, so 1 plus 2 is 3, and this subarray that just has one element. And again, the output is 2. It also gave us several constraints about the variables. For example, the length of nums is from 1 to 2 times by 10 to the power of 4, and each element of the nums array could be from minus 1000 to 1000. And this is important because it means that the elements of the nums array could also be negative. And k is from minus 10 to the power of 7 to 10 to the power of 7. Now, let's take a look at the suitable algorithm that we can solve this problem with. To understand the algorithm better, let me explain that with an example. So consider this is the nums array that we have, and k equals to 1. So we need 3 variables to solve this problem. The first variable is called sum, and it shows sum of the numbers from the beginning of the nums array to the current index. So for example, if we are here currently, sum equals to 1 plus minus 1 plus 1, which is 1. And the second variable that we need is the answer, which is the output that we have to return at the end of the algorithm that shows the number of continuous subarrays that the sum of them are equal to 1. And then we also need a map of integers to integers that I call that occur or occurrences. And it shows the occurrences of sums that we have in the nums array. So for example, when I'm at the beginning, first cell of this array, the sum equals to 1. And its occurrence equals to 1 because I have seen that once. And when I'm here, again, the sum equals to 1. And as I have seen 1 twice, so the occurrence will be updated to 2. So it's a map from sum, the sums that we have, to the occurrences of each sum that we have. Now let's solve this example to understand the algorithm better. So k is 1, and initially sum and answer are equal to 0 because we haven't started iterating through the array, so we don't have any sum. So we begin from the first cell of the array. Now sum equals to 1, and the map, let me also erase these things. So we have to put 1 in the map also. So the sum that we have, let me do something first. So let's move them here and then write the variables beneath them. So the sum equals to 1 now, and its occurrence is also 1. And the answer that we are looking for, the way that we calculate that is that on each cell of the array that we are, we calculate sum minus k, and then we check our map. So if we have any occurrences of sum minus k, then we add that to the answer.
Now you might be asking yourself, why do we use sum minus k?
To explain it, keep two things in mind. First of all, we don't know the locations of k's. And second, the sum that we have here is a cumulative sum, so it shows some of the numbers up to the current index. So based on the question, on each iteration, we want to find the subarrays which are ended to the current index and their sum equals to k. But as we don't know where these subarrays are, we find them using sum minus k. Hence, we count number of sum minus k's instead of k's. And the reason that we can't do this is because k and sum minus k are having a bijective relationship, which means if there is any k in the subarray, we have a corresponding sum minus k for that. Now, let me show what do I mean on this array. So consider that the current index is here. So the value of sum would be 1. And now I want to calculate sum minus k. So sum is 1 and k is also 1. So sum minus k will be here. And it equals to 0. And with this move, I will find k, which is here, and is equal to 1. And keep in mind that k is the subarray that should be ended to the current index that we are in it. And as we do this on each iteration, we find all the k's at the end of the algorithm. Now let's solve the rest of the example together. So for example here, sum minus k equals to 0. And as we have, also I forgot to write it at the beginning. At the beginning, we consider that we have one occurrence of 0 because at the beginning sum is 0 and actually we have one occurrence of that. So now that we calculate this and the answer is 0, we have one occurrence of 0 in our map. So we update the answer and add 1 to answer. So 0 plus 1 is 1. Then we continue the iteration. Okay, now we are on -1 and the sum to this point from the beginning of the nums array equals to 0. So the occurrence of 0 is 2 now. And then we calculate this, which is -1 now. And we look at our map, so we don't have any -1, so we do not update the answer. Then we continue our iteration. Now the sum equals to 1 again. So the occurrence of 1 in the map is 2 now. And 1 minus 1 is 0. And we have that in our map. So we add its occurrence to the answer. So 1 plus 2 is 3. And then we continue the iteration. The sum is 0 again. And the occurrence of 0 is 3 now. But 0 minus 1 is -1. And we don't have any of that in our map. So, and when we continue, and we cannot also continue the iteration, so this is the final answer that we have. So we have 3 continuous subarrays in our nums array that the sum of them are equal to 1. And let me show them too. So the first one is this, and the second one is this subarray, and the third one is this subarray. Okay, now I think we understood the algorithm. It is really simple and easy to understand. So now let's move on and see the suitable code for this algorithm. To implement the algorithm, I wrote this function and I called that Subarray Sum. And as you can see, it takes 2 parameters or 2 inputs, the nums array and k. Initially, I declared the map that we have, a map of integers to integers, and then sum and answer, and I put 0, 1 as the first element into the map. As you remember, we had 0, 1, so the sum that equals to 0, which is the initial value, has 1 occurrence. And after that, in this for loop, I iterated through the nums array. So initially in the for loop, I added num to the sum to calculate the sum from the beginning of nums array to the current index. And then I calculated the answer using the sum minus k formula that I explained in the algorithm section. So if there is any sum minus k in the map, we just add that to answer. And if it's not, so it means we don't have any occurrence of that, we add 0 to the answer. And here I wanted to update the map. So I got the occurrence of each sum that we have. And if there is any sum, so we assign it to count. And if there is not any sum that we have, we just assign 0 to count. Then I have put it sum count plus 1 to the map. And this plus 1 is because we just found a new occurrence of sum. So we want to update its occurrence or its count. And after the for loop, I returned the final answer. Now let's submit the code in LeetCode.com and see how our code is doing. So it's been accepted, and as you see, it's a really simple problem. So the code and algorithm are both so easy to understand if you understand the intuition of the work that we are doing here. Now let's talk about space and time complexity of this algorithm. The time complexity of this algorithm is an order of n, because in this for loop we iterate through each item of the nums array once. And you may ask that what about this map that we are using? So the get and put method of the map in Java has the order of 1, so it doesn't affect our time complexity. And the space complexity is also the same, because we just store a map that sums of the numbers in our nums array.